Hello students, today let us study a new topic that is derivatives. Now basically, what is a derivative? Derivative is defined as the gradient of the tangent at a point. So derivative is the gradient of the tangent at a point. Already you have studied how to find the gradient of a line segment. So gradient is defined as the difference in y coordinates divided by the difference in x coordinates, y2 minus y1 upon x2 minus x1. So to understand the concept of the derivative, I will put a graph here. So here you can see there is a curve y is equal to fx. So the equation of the curve is y is equal to fx. Now on this curve, I am taking 2 points here. One point is A, another point is B. Now x coordinate of A, it's say x. Then what are the coordinates of point A? X, and y coordinate is fx because the function is y is equal to fx. Now suppose the distance on x-axis between the x coordinates of the 2 points here is h. That means for B, the x coordinate will be x plus h, and hence the coordinates of B will be x plus h, f of x plus h. Now if I join points A and B with a line segment, that is called as a chord. This is chord AB. Chord is a line that will intersect the given curve in two distinct points. So the gradient of the chord AB is difference in y coordinates, that will be f of x plus h minus fx divided by difference in x coordinates, that is x plus h minus x, which is f of x plus h minus fx upon h. Now what I'll do is I'll keep the point A fixed on the curve, and I will move point B along the curve towards A. So I'll put the diagram here. So as you can see here, I am moving point B towards A on the curve. So as B moves towards A on the curve, what is happening to H? H is becoming smaller and smaller. So finally H becomes so small that the chord AB tends to become a tangent at A. Okay, let me explain this concept. Now, B is moving towards A. H is becoming smaller and smaller. Finally, H will become very, very small. That means points A and B will merge with each other. When A and B will merge with each other, what will happen to the chord? Chord will tend to become a tangent. So this is called as the limiting case. Let me show this with a diagram to you. So as you can see here, H is becoming smaller, smaller, and finally it is becoming so small that it will tend to 0. I am saying tending to 0. That means it is not actually becoming 0, but very, very small. In that case, points A and B will come so close to each other. That means the chord AB will now become as good as a tangent. What is a tangent? It is a line that will touch the curve in one point. So when point A and B will merge with each other, the chord will tend to become a tangent. So I will say that the gradient of the tangent at A, I'll call this as the limiting case. Limiting case is written like this. Limit as H tends to 0. The meaning of this is H is becoming smaller, smaller and smaller, and finally it will become as good as 0. When H will become as good as 0, points A and B will merge into each other. In that case, the chord will tend to become a tangent. So I'll say that the gradient of the tangent at A is the limiting case as H tends to 0 of gradient of the chord AB. But already we have seen that the gradient of chord AB is f of x plus h minus fx upon h. But by the definition of the derivatives, the gradient of the tangent at A is the value of the derivative at A. So I will write this as f dash x or even dy by dx. So this is called as the definition of the derivatives. So let me just go through this concept once again. So first of all, AB is the chord. and coordinates of A are x and fx. Coordinates of B are x plus h, f of x plus h. So gradient of the chord will be f of x plus h minus fx upon h. That is the difference in y coordinates upon difference in x coordinates. Now, what I am doing is keeping a fixed on the curve. I am moving point B towards A. So as B is coming closer and closer to A, h is becoming smaller and smaller. H is the distance between the two x coordinates of A and B. So as B is moving towards A on the curve, h is becoming smaller and smaller, and finally h will become so small, I will say that h is tending to 0. In that case, point A and point B both will merge with each other. When A and B will merge with each other, the chord AB will tend to become a tangent. That means I will say that the gradient of tangent at A is the limiting case. Keep it in mind when I am saying limit as h tends to 0, h is not actually becoming 0, but it is coming very close to 0. For example, maybe 0.000001. Okay, so the gradient of tangent, I can say that it is the limiting case as h tends to 0, gradient of chord AB. And we have already seen that the gradient of the chord AB is f of x plus h minus fx upon h. But by the definition of derivatives, the gradient of tangent at A is the derivative of fx at x is equal to A, which I can show by dy by dx or f dash x. And this is sometimes called as the definition of derivatives or the first principle of the derivatives. So wish this concept is okay with you. So in the next class, we'll see some problems on this first principles. So today as a homework, just go through this concept. So see you students. Bye. See you in the next class with some problems on derivatives.